Yeah, so thank you so much, Matt, for inviting me. I'm super excited to be here. If you can tell from my accent, I flew out from San Francisco for this, but it's worth it. So I'm excited to be here. Um, yeah, so basically, I'm going to talk a bit about a tool called Semgrep, which is just sort of like a generic tool to like easily find code that you're interested in. You can think of it as like a code-aware grep. I must confess, it's not actually written in Ruby. The core of it is OCaml because we have some sort of fancy program analysis PhDs working on it. I'm not good at OCaml, but they are way smarter than me. But basically, I want to tell you a bit about this tool. It's open source, and hopefully you may find it of interest. So here's sort of the motivation. So I think many of us have, given a code review for a friend at our company where it's like, hey, you're doing this thing. In this example, say ensure user, but really like we do things differently now. And sort of the point here is like every code base has sort of implicit assumptions or requirements about how we code, maybe coding standards, and really there are some tools that have a bunch of nice checks out of the box, right? So we have like Rubocop and Breakman for security. And those are great tools. But the problem is oftentimes there are things like specific to your code bases or specific to your organization that we would like to find that, aren't generic things that are going to come out of the box. So sort of the core idea I'm trying to get at in this talk is it would be nice if we could take coding standards, whether they're in sort of like a wiki or just in the code itself, or maybe just in our brains and like we haven't written them down anywhere. And ideally, like take those sort of implicit assumptions and then enforce them continuously in CI, whether that's like GitLab, GitHub, Travis, or so forth, as sort of like some lightweight lints. So why do we care? Why is this useful? Ideally, this can help our colleagues who are new developers get up to speed faster. Hopefully, we can ship higher quality code and more quickly. If our organization is growing rapidly, we can have like a high code quality standard that we can maintain. Maybe if we have certain known bugs, like if you call this function with this parameter, it's a bug for whatever sort of domain specific reason, we can sort of block that from coming back into our code. And ideally also we can prevent security vulnerabilities. So these are like a couple of examples of why we care about doing this. So super briefly about me. So I'm head of security research at R2C. We're a San Francisco-based startup, which means we only drink kombucha out of mason jars and wear skinny jeans. Before that, I was a security consultant at NCC Group, and before that, I was a grad student, where of course I dressed like this, as all grad students do. So feel free to reach out on Twitter. I also have a security newsletter that you can check out if you want. Okay, so this is the structure of the talk. First, a little bit of background, but most of the talk is just going to be like hands-on examples of using this open source tool called Semgrep. Then I'll talk a little bit about more advanced features and some other sort of stuff, and hopefully have a bunch of time for questions. Okay, so why aren't we just using grep? I think this is an important question. So grep is a great tool, but fundamentally code is not a string, which is how grep operates on it as sort of just a regular expression. Really code is a tree. Like this is how a compiler or an interpreter views your code. So here, sort of on the left-hand side, this sort of text depends on the language, but probably is represented like a tree like this, where it's like, oh, this is a conditional, this is a function definition, this is a module, and things like that. So ideally, we want to be able to reason about code, not just like as a string. So the tool I'm going to be talking about, Semgrep, we actually didn't build it originally. It was created by Facebook, where they used it to enforce over 1,000 different secure coding patterns. Basically, it's sort of like a lightweight static analysis tool, sort of like linting, if you will, for easily searching code. There's hundreds of community rules across various languages, including Ruby, but also a number of others like Python, Go, Java, JavaScript, C, and a couple of others. So it runs offline, has an nice CLI. You don't need to compile the code in any of these languages. Obviously, Ruby is interpreted, but some tools require you to compile, say, Golang or Java to analyze them. But I think like really the coolest part is a number of these other tools, and we'll get some examples. You have to learn this sort of like complicated DSL to write a custom pattern in that tool. But here, basically, if you want to match Ruby code, you just write Ruby that essentially looks like the code you're trying to find with a couple of helpful abstractions. Okay, so let's like look at some examples of say Rubocop and Breakman and just see how that would look in Semgrep. So on the right-hand side, let's say we want to find calls to eval because maybe we're like, hey, this is kind of dangerous. We don't want people to use eval. If an attacker could provide input to it, they could sort of run arbitrary Ruby. So here, this is what it looks like in Rubocop, where basically they're doing an S expression matching. I'm not going to really walk into the details, but just it's like, okay, there's like some sort of domain specific stuff we need to learn here. So there's the semgrep.dev is basically a live editor where basically in the background, it'll spin up sort of a temporary Docker container to run your pattern. So basically you can type in what you want to find here, and then you could put test code you're trying to match here. So this is an example of like why we would want to use something that's code structure aware rather than grep. So if we were to write, say, a regular expression to find this, it's like, well, like sometimes there's like open parentheses, sometimes there's not, sometimes there's white space. This function isn't actually eval, it just happens to end with eval. There could be like white space. And also if we were just writing a regular expression, probably we would like match in this comment, which is not actually code. We might match inside like a string literal. These are all just examples of like, probably it's going to be super annoying to write like a very fancy regex to find all these cases. So basically what we can do is type in eval, open parentheses, and then ... So this is in Semgrep called the ellipsis operator, which basically means I don't care about the arguments. There can be 0 or more. So if we run this, we can see that we found both of these cases. It doesn't matter that there's parentheses or not, like white space is okay. It didn't match this because it's not actually eval. We found across multiple lines. And also importantly, we did not match the thing in a comment or a string literal. So you can actually combine clauses in Semgrep where you can say like find this and that, or this but not that. So let's say we were like, oh, I don't want to find things that are a constant string because that's not dangerous. So we could say eval, match any eval, but not ones that are, say, a hard-coded string. So this sort of ellipses inside 2 quotes says the argument is a hard-coded string. So here we filtered out these 2 cases because it's just a string literal, but we did match these variables, which again are sort of potentially dangerous. Okay, so this is an initial example, but any questions so far? I've got like 1 or 2 that show a couple of other features, but yeah, feel free to interrupt me whenever. Either
what about
in
if there's string interpolation there?
Yeah, that's a good question. So here we will still find that because it's not just a string. But that's a good question. Are you saying like, how do we find like only if there's a string interpolation, or?
I was sort of meaning that like you were saying that hard-coded strings are not a problem, but that found the hard-coded string as well.
So this
the interpolated one
is foo is a variable and it's being interpolated into the string.
Oh, sorry, I got it backwards. So it found that one as a bad one. Yep, got it. Cool.
Cool. Yeah, thanks for the question. It's a good one. Cool. I will start going on, but again, feel free to interrupt me whenever. That's much more fun than just me blabbing. Okay, so this is an example of a Breakman rule where they want to find divisions by 0. So this is on the right, what it looks like in Breakman. So it's like, hey, we're getting sort of the caller and the first argument, and then it has sort of like a number helper function looking at sort of the denominator. Okay, so again, let's see what this might look like. So we're going to learn, so there's like basically 2 abstractions on top of source code in Semgrep. One is the ellipsis operator, which is like match 0 or more things. The other is called a meta variable, which is basically like a $sign and then all case and sort of like a capture group in a regular expression where it's like, I don't know what this is, but I want to match it. So if we do this, we're saying like anything divided by 0, find that. So again, like it matches like the 3 here. Even if this is a variable assignment, like that's okay. So we're finding a couple of different things, but we're not finding this case, right? Because it's like assigning a variable to 0 and then using that variable later. So it'd be nice if we could find that too. So we could say, all right, so match what we already are matching, but let's also match, let's say, if some variable is assigned to 0, and then something happens, and then there's like some other thing that is then divided by the first thing. So if we add that, we can see that we did flag this case as well. So what's cool here is meta variables are sort of enforced to be the same within the same pattern. So here, basically, this x and this x are the same. So then we can catch this case as well. And this ... matches 0 or more statements. So if I were to say, like, something else, I don't know, like put a couple of statements here, this ... is going to match these intervening statements because they sort of don't matter. Cool. So yeah, basically, ... sort of a blanket wildcard, and then meta variables are like, oh, match this thing, but I don't know what it is ahead of time. Yeah, any questions?
No, but that's really cool.
How would you exclude the case of if you were assigning 0 to 1 in between those putters?
So like reassigning x.
Yeah.
Like in the middle there. Yeah, so you could like perhaps add like a filter out case that would check for like this variable being reassigned. There is, so in certain languages like say Python or Go, and I think maybe Java, we do have some support for something called constant propagation, which is basically like, is this thing a constant value? We know it doesn't change, and then we can sort of propagate that across many statements. Because Ruby is a dynamic language, there are certain things like that that we can't do as effectively. So there is sort of like trade-offs between languages. So we could sort of approximate that, I think, with adding a case that would check for that reassignment. But if it were to happen, if it were to be reassigned and basically very complicated things were to happen, it could be difficult to express every possible manifestation, but I think you could do a pretty good job with some sort of like custom filters, perhaps. Yeah, is that a question?
Thanks.
Cool. So this is a very short time slot, so I will wrap up very quickly. I'll just maybe show this to you. Oh yeah, so in each of these, and I have a link to the slides at the end, but there's sort of like a link if you want to try it, and then there's like a solution link. So let's say there's an application, this is an example of finding a business logic flaw. So let's say you're like, oh, we need to call foo before bar, or if bar isn't called after foo, it's like a bug. So in this example, let's say there's a financial trading application where you need to call verify transaction before you call make transaction, or else it's a bug. So this is basically how you would do that. You could say find every method, and again, I don't care what the method name is, that calls make transaction anywhere inside it, and then filter out the cases where verify is called before make. So basically, this is going to find instances of that business logic bug occurring in practice. So you can see here, verify and then calling make is okay, but calling make without verifying is not okay. If you call them in the wrong order, that's not okay. If you call just verify, that's okay. There can be other statements in the middle. And this last case, I think, is kind of interesting. So here we are creating one transaction object and verifying it, but the transaction we're making is actually a different one. And the way that we're able to find that is that basically this meta variable t is the same in both arguments. So we're enforcing that the arguments to verify and make are the same. So that also catches this sort of business logic bug. So this is just one example, but the idea is like if there is domain-specific logic in your code that you want to enforce, ideally sort of the goal of Semgrep is like, how do we take what's in your brain and make it in code as sort of like a simple code search as easy as possible. That's basically the point. So let's see, I'm going long, so I'm just going to blaze through the rest of it and leave it open for questions. So you can also put arbitrary Python code. So like the meta variables you match, you can sort of do whatever you want on them. The rest of the people in my company are big fans of Python. Thus it's Python. Sorry, it's not pattern-aware Ruby, but maybe in the future. We want to not just find things. Ideally, we want to help people fix it, right? We don't want like to just point out problems. So there's actually support for adding like an auto fix. So like, hey, if I find this, change it to this. I just showed like a couple of examples of the types of patterns you can use, but there's many more. If you check out the docs, there's a tutorial that you can go through that has a bunch of examples. So we looked at writing rules, but there's like, I think a little over 1,000 rules for 6 or 7 languages that come out of the box. They're just YAML files on GitHub that you can check out, but also there's like a nice UI for them. These are just examples of like people in the community, not just our company writing them. So the author of this Go perf book wrote a bunch of rules, Node.js scan, and basically there's just like a bunch of people writing stuff. And some of the OWASP, if you're familiar with OWASP, it's like a sort of open security group. They've been writing some stuff and helping us. If this sounds cool and you want to hook it into CI, that's actually pretty easy. There's like a Linux binary or Docker container. We've got example configs and GitHub Actions. So basically whatever sort of CI thing you have. Ideally it's supported. If not, we can dump the results to JSON so you can parse it yourself and do whatever you want. Yeah, so that's basically it. Ideally, you can write code specific or organization specific lints that save you some time on code review. And yeah, it's open source. It's on GitHub. Feel free to go there for these slides if you want to check out some of the resources later. But yeah, thanks for your time. Happy to answer questions or just yield to the next person. But yeah, thanks for having me.
Great, thanks, Clint. That was great. It was really interesting. I could see a lot of things where I'm like, yep, definitely want to use that. And yep, that was really cool. Does anyone have any questions for Clint? Oh, we've got something in the chat here. Clapping hands. Cool. Maybe we can. I can grab that link off you afterwards as well, and we can share. I'll post it up on Twitter if people are looking for the slides. Yeah, that's cool.
Sorry, I've got a quick question. So this tool looks like a great thing to add into like a sort of a blue-green refactor cycle during development. I was wondering if you, on any Ruby projects that you've used this with, whether there's like a guard integration or something like that, where you know, as well as like sort of running my tests all the time, it could run something like this, sort of, you know, as long as all my tests pass, then it sort of checks the, you know, the code-based business rules.
Yeah, totally. Let's see. So there is, yeah, so I think guard, we haven't played with that specifically, but I think that should be easy. Really any sort of like get pre-commit hook or anything that can allow you to run like an arbitrary command line tool would be easy to do with Semgrep. We have played a bit with pre-commit, which is, I think, basically very similar to guard. There's also a VS Code extension that's like pretty alpha stage, to be honest, but it does work. Where basically, if you install it, you can point it at a set of rules that basically like it'll highlight it in your IDE. It's actually helped me find some bugs where I was like doing the wrong thing. Yeah, so there are a couple of ways, either with like guard or pre-commit to check before you commit, or just to get live feedback in VS Code. We're working on other editor integrations, but VS Code is what we have now. And I think, yeah, there's a couple of like rule sets that we've sort of specifically tried to make like high signal to put in CI. So like R2C CI, for example. But yeah, thanks for the question.
Awesome, thank you.